Hi everyone, we're going to start adding probabilities, and there's two main new words you need to know is mutually exclusive events and inclusive events. And you all can read this. I wanted to go over the probability of A or B. This also can be written as A or B. And the reason I write it this way is so some people that might be learning this have not got into set theory yet, so I'm doing it both ways, but just know that it's this way. And these are actually harder than multiplying. So the main thing you need to know is adding probabilities has to do when you see the word or. All right, and also this symbol, the way I remember this symbol is I put an OR, or, so it has two ups. This is the and, so this equals and. But I'm just going to do the or. Now, inclusive events mean that when you did this probability of the event A and B, this included some of the probabilities. You have to subtract it back out. And I think the best way to talk about this is just do some examples. All right, so we're first going to do a mutually exclusive event example. So what's the probability of drawing a jack or a king? So there are 4 jacks in a deck of 52, so that's 4 out of 52. You see the word or, so we're going to say plus. And so that would be, what do we need now? 4 kings. So there's 4 kings also, and you just add it up. These are separate, the jack and the kings. So when you add that up and multiply it out, you're going to get 2 over 13, which equals approximately 0.154. Now, to show you the difference between these two, let's look at this one, and then you'll know what the difference is. Okay, what's the probability that it's a red card or an ace? So the red card, we'll call this A and this B. The probability of A is 26 over 52. Now we know that's 1/2, but I like to keep it in this form and not reduce it. The probability of B, there's 4 aces, so that's 4 out of 52. So basically you would add these. And the reason I like to keep them the same is because then when you add these, you can just get 30 over 52. You don't have to use the calculator. The problem with this is that 2 of the red cards that we did here are aces, because there's 2 red aces and 2 black. So we counted 2 of the red aces twice. Since we did that, we're going to subtract them back out. So we're going to subtract the 2 red aces out. And then that's where this formula comes in. All right? So we're going to subtract that back out, and you'll get basically 28 over 52. Or you can just use your calculator. And that would be 7 over 13, or I'll just leave it like that. All right? Okay, so that's the difference between the two. When you include when you counted something twice, basically, or 3 times sometimes. All right, let's look at some more. Are these events inclusive or mutually exclusive? And then we have to find the probability. What is the probability of selecting a king, a queen, or a red card? So we know so we have a A and a B and a C. So the probability of a king, and this means or too. When you see the or here, that means it's all or, not and. So probability of a king, there's 4 kings, or a queen, or a red card. Now, do you think this is inclusive or mutually exclusive? Well, we know there's 2 red kings and 2 red queens. So we're counting 4 cards twice, so we have to subtract those out. So this one's inclusive. We included them in this total in here. So we subtract out the ones we doubled up on. And then what you'll get is 30 over 52, which is, so it's inclusive. We have to write that. And which gives you about 15 over 26, which is approximately 0.577. All right. This one, we have 45 eggs, 15 yellow, 12 green, and 18 red. What's the probability of selecting a green or a red? So that means we're going to add. That's what this video is about. So green is what? 12 over 45. And then or a red. So that's 18 over 45. Now, these are exclusive, mutually exclusive, because we didn't count anything twice here. So that's going to be 30 over 45. 15 goes into both of those, so that would be 2/3. All right? Now, here's another one. The letters of an alphabet, we're going to do 26 letters. There's 5 vowels. I know this one's kind of hard if you don't speak English, but our vowels are A, E, I, O, and U. So, what's the probability of selecting a vowel? So that's 5 out of 26. Or these letters, that's 4 out of 26. However, there's 2 vowels in this word. We have U and I. So we subtract what we counted twice in here and here. So that's minus 2 out of 26, which is going to give us 7 out of 26, which is approximately 0.269. All right, the next video is going to be the same thing, but more, and they're going to be a little more complicated. We're going to get into word problems that says at least and at most, and things like that. So make sure you know what inclusive and mutually exclusive means before watching the next video, and you'll have a nice day.